Hi, welcome to #Math. We're going to sketch graphs of rational functions that have oblique asymptotes. Let's go. Okay, so we want to graph the function f of x equals x minus 3 squared over x minus 1. First of all, let's find the domain, which is very easy. The domain of f is the set of all real numbers except what makes the denominator 0? 1. Okay. The y-intercept, find f of 0, which is 0 minus 3 squared over 0 minus 1, which is 9 over negative 1, which is negative 9. And we record it here, negative 9. The x-intercept, that is when the numerator is 0. Where's the numerator 0? At 3. So my x-intercept is just 3, 0. And we record it here. Okay, do we have vertical asymptotes? Yes. X equals 1, the one that makes the denominator 0. Let's record it. For the behavior near the vertical asymptote x equals 1, we see that the y-intercept here is telling us that to the left of the asymptote, the graph is negative. So when we approach 1 from the left, it's negative. That means that as x approaches 1 from the left, f of x approaches negative infinity, like this. Since the multiplicity of x minus 1 is 1 odd, then from the other side, it has to approach positive infinity, like this. Now, since the degree of the numerator is 2, which is by 1, bigger than the degree of the denominator, which is 1, we know that the graph has oblique asymptotes, and we must find them. For that, we FOIL x minus 3, which is x squared minus 6x plus 9, and that's over x minus 1, and divide and perform long division. So we have x squared minus 6x plus 9. No gaps, we're fine, we just divide. Take the first term here and the first term here and divide x squared over x. That is x. That's the first term of the quotient. Then multiply x times x minus 1, which is x squared minus x, and subtract. Change signs. Negative x squared plus x. Now we add. This, of course, cancels out. We get negative 5x. Lower the 9 and do the same procedure. Divide negative 5x by x. We get negative 5, that is the second term of the quotient. Multiply negative 5 times x minus 1, which is negative 5x plus 5, and subtract, change signs. That's 5x minus 5, residue is 4. Now the slanted asymptote is right here. The slanted asymptote is y equals x minus 5, and we record that. To graph this line is really easy. Y-intercept is negative 5, and then we go 1 up, 1 to the right, 1 up, 1 to the right. And we're ready to graph. We're going from the x-intercept to reach the asymptote towards positive infinity. Then from there, I have to reach the oblique asymptote now to positive infinity. We need to reach the oblique asymptote towards negative infinity and the vertical asymptote towards negative infinity. Done. And this is the graph done in Desmos.com. Let's go to our second example. To graph g of x, we factor as much as we can first. Let me factor a negative sign here first. That's x squared plus 2x minus 3. Let me factor a negative sign in the denominator to make this look nicer. Negative and negative is going to be positive, and let me factor the top. Okay, so let's graph that. The domain is the set of all real numbers that are not what? You already know, of course, negative 2. The y-intercept. For that, we set x equals to 0, so we do g of 0, which is 0 plus 3 times 0 minus 1 over 0 plus 2, and that is just negative 3 over 2. So the y-intercept is negative 3 halves. Let's record that. Okay. The x-intercepts. Where is the numerator 0? At negative 3 and at 1. So we have two x-intercepts, negative 3, 0, and 1, 0. Vertical asymptotes. There's only one vertical asymptote. X equals negative 2 because x plus 2 does not cancel out with anything in the numerator. Let's record that. Negative 3 is 0 is one intercept. 1, 0 is the other intercept. And we have a vertical asymptote at negative 2. To analyze the behavior near the vertical asymptote, we can use the y-intercept here. That's telling me that the graph to the right of the asymptote is positive. So to the right of the asymptote, but before this intercept. Remember, the graph is going to change signs before and after any x-intercept, of course. The y-intercept is before the x-intercept, so we're fine. The y is going to work. That tells us that as x approaches negative 2 from the right, g of x approaches negative infinity, like that. If you see the multiplicity, that means that when you approach -2 from the left, it will go to positive infinity. The degree of the numerator is by 1 bigger than the degree of the denominator, so we know we have an oblique asymptote and we must perform long division. Let's do it. We must divide -x squared minus 2x plus 3 by -x minus 2. And we'll do the same. -x squared divided by -x is x. Then you multiply x times -x minus 2, which is -x squared minus 2x, and subtract. Change signs. That's x squared plus 2x. And add. They cancel out. These also cancel out. And we get just a 3. So we're done with the division. What's the slanted asymptote? Here, just y equals x. To graph y equals x, that's the identity. The y-intercept is 0, and you go 1, 1, 1, 1. Okay, and we're ready to graph. Notice that the x-intercept here is to the left of the oblique asymptote, telling me that I am going to approach the oblique asymptote like this. In the same way, those points I have here on the right tell me that I have to approach the oblique asymptote like that towards positive infinity. Okay, now let's graph it. We go here from asymptote to asymptote, going through that x-intercept, go from here to the x-intercept, and then up to approach the vertical asymptote. And on the right, same thing. We go from -infinity or vertical asymptote, touch the y-intercept, the x-intercept, and approach the oblique asymptote. And we're done. That's the graph. This is the graph done in Desmos.com. Our last example. Let's graph h of x. What's the domain? So the domain of h is the set of all real numbers, and we have to find out when the denominator is 0. That's when 2 minus 2x equals 0. Bring the 2x to this side, so add 2x on both sides. So 2 equals 2x, and then divide by 2 both sides. X equals 1. So it's all real numbers except 1. For the y-intercept, we set x equals to 0, so y is h of 0, which is 2 times 0 squared minus 6 times 0 plus 5 over 2 minus 2 times 0, and that is 5/2. So the y-intercept is 0, 5/2, and we record it. Okay, the x-intercepts happen when the numerator is 0. But if you observe that polynomial in the numerator, we cannot factor it. So we have to do what? Quadratic formula to find x, and then we get x. So we apply the quadratic formula. X equals -b, which is 6, plus or minus b squared, which is 6 squared, 36, minus 4 times a, which is 2, times c, which is 5, over 2a. Look what's happening. That number is bigger than 36. That's 40. So the discriminant is smaller than 0. That means that the solutions are complex, are not real. What does that mean? This graph does not have x-intercepts. So no x-intercepts. We've already seen that x equals 1 makes the denominator 0, so our vertical asymptote is x equals 1. Let's record that. For the behavior near the asymptote, again, the y-intercept is going to help us. It's telling us that to the left of the asymptote, the graph is positive. So as x approaches 1 from the left, h of x approaches positive infinity. So we have oblique asymptotes and we must perform long division. We want to divide 2x squared minus 6x plus 5 by, and then the denominator I have to order it. It has to be in descending order. So I have to write -2x plus 2. And we do the same thing. Divide the first term of the dividend by the first term of the divisor, and we get -x. Then multiply -x times -2x plus 2, which is 2x squared minus 2x, and subtract. So change signs. -2x squared plus 2x, and add -4x. Bring down the 5 and do the same procedure. Divide the first term here, -4x, by the first term here, -2x, and we get just 2. So that goes to the second term of the quotient. Then multiply the 2 times -2x plus 2, which is -4x plus 4, and subtract. So change signs for x minus 4. We finished the division. Where's the oblique asymptote? Here. The graph has an oblique asymptote. Y equals -x plus 2. And let's graph that oblique asymptote. The y-intercept is -2, and it goes down, one to the right, one down, one to the right. Oops, I forgot to put the lines. As x approaches 1 from the right, the graph goes up because the exponent is odd. From the other side goes down. Because this point is to the right of this asymptote, it has to be approached from this side. And on the other side, it's going to approach negative infinity, like that. And we are ready to graph. I guess you can see it. From my asymptote all the way to my x-intercept to reach the oblique asymptote, like that. And then here from asymptote to asymptote, like that. Nice, huh? I like it. And this is the graph done in Desmos.com. Thank you.